So, uh, Today I'm going to talk about uh, rational numbers, and I'll focus on the definition of irrational numbers. So, here I've written the definition, and the definition is an irrational number is a number which is neither terminating nor recurring. What does that mean? It means that irrational numbers are those numbers which, I'm talking about decimal numbers here. Uh, we are considering decimal numbers here. So those decimal numbers which are neither terminating nor recurring. And recurring, what does recurring mean? Recurring means a thing is happening regularly or repeatedly. And terminating means that it ends at some point. So, what kind of numbers are these which are neither terminating nor recurring? It means those decimal numbers whose decimal places either they neither end nor do they continue forever. Look at the examples here. So the first example I'm considering for irrational number is pi. So pi is equal to 3.141592656 up to so on. This continues and goes on. Look at this decimal number. It's a decimal number because it has a decimal in it, this point. And when we look at the decimal places, I mean the digits which are coming after the decimal, those digits, they don't get terminated, they don't end, they keep going on forever, and they don't repeat. They are different, they don't have a pattern to them. 1 4 1 5 9 2 6 5 3 6. These digits have no pattern in them, and they're not ending here. They're not ending here. I've just written uh, these decimal places up till this point. They go on forever, but they won't repeat, they won't follow a pattern. So this is an irrational number. Pi is an irrational number. Similarly, square root of 2, when we look at its decimal form, it also goes on forever, and it also, meaning it's not terminating because it's going on forever, and its decimal places are not repeating either. They are different: 4 1 4 2 1 3 5 6 2 4. So the digits are not following a pattern. So this is also an irrational number. And square root of, basically, any number which is not a perfect square is an irrational number. You consider square root of 3. 3 is not a perfect square, so square root 3 is also an irrational number. Square root 5 is an irrational number. Square root 6 is an irrational number, because these 2, 3, 5, 6, these are not perfect squares. So they always give us, they are irrational because their decimal places are like this. They go on forever and they don't repeat. Next example which I am considering here is Euler's number, E. This is a very famous number in mathematics, and it is also irrational. When you look at its decimal places, they don't repeat, they don't follow a pattern, and they also go on forever. They don't end at any point. 7 1 8 2 8 1 8 2 8 5 up to so on. So this is the definition of irrational numbers. The opposite of irrational numbers are rational numbers. When we look at them, these are the kind of numbers who either get terminated or continue or follow a pattern. 0.25, that's the end of it. There are no decimal places after 5 here. Similarly, here is another example of rational number, 0.3333 up to so on. This continues on forever, and we can see that this clearly has a pattern. 3 its decimal places are just 3, and 3's just keep on repeating. The next thing which you'll notice about irrational numbers are that they can't be written in the form of fractions, because the numbers which can be written in the form of fractions are rational numbers. They are not irrational numbers. We are calling these things as irrational numbers, and we can see that these numbers can be written in the form of fractions. 0.25 can be written in the form of fraction, 1 by 4. 0.333 up to so on can be written in the form of a fraction, 1 by 3. So, but when you look at these numbers, 3 point, this number, this number, this number, these can't be written in the form of fractions. If you write them in the form of fractions, those fractions won't be exactly equal to these numbers. For example, a rough approximation which is used for pi generally is 22 by 7. But 22 by 7 is not equal to pi. It is approximately equal to pi. So 22 by 7 is technically not equal to pi, and so that's why it is in the form of fraction. Pi cannot be written in the form of fraction. So two things. Firstly, these are the numbers which don't end or which don't repeat. Their decimal places don't repeat, and their decimal places don't end. And the second thing is that they can't be written in the form of fractions. If you write them in the form of fractions, those fractions basically, they are not the kind of fractions which we see when we see rational numbers. For example, you can write the square root 2 as square root 2 over 1. That would be a fraction, but that would not be a fraction like the fractions like these fractions, 1 by 4, because in this fraction both the numerator and denominator are integers. Square root 2 over 1, when we write that fraction, square root 2 is not an integer, because integers are -1, -2, -3, 0, 1, 2, 3 up to so on. Those are integers. But even in these rational numbers, denominators can't be 0, because that would make these fractions undefined.